Perfect? Yes. Now, the variation at the aircraft is 20 degrees, and this is the variation at the NDB. Now, to transfer these values, the tracks to the chart over here, you have to apply variation. You're going to convert the magnetic value which you got here to true value which you're going to put on the chart. Right? You have two different variations now because NDB and NDB and the aircraft are at different locations. Which variation are you going to use? That is the whole idea about this discussion. Otherwise, I'm pretty clear. You know the question part of it. We have done numerous questions based on this. All right. Yeah, exactly. So that's the whole idea. Did you get why? Yeah, you can take some time. Think about it. I'll give you maybe 2 minutes. We have discussed this in VUR as well, a bit here and there, because I wanted to keep it as a kind of a question to think about. I'll give you some time. Think over it. Also, the guys who are streaming up there, think about it. Which variation would you prefer? Probably use 15 or 20. All right. Yes, that's it. That's it. Well done. I did get a couple of good answers here. Very, very solid answers here. Definitely making me happy. So let's find out. Now, to understand this better, so definitely I would probably take the variation at the aircraft, right? I'll be taking the variation of the aircraft, which is 20 degrees. So 20 degrees east is the variation. So the QDR is 155. Magnetic 20 degrees east means magnetic is least, and therefore the true will be 155 plus 20, right? And that's going to give you 175 degrees. Now remember, this is now true, right? Now let's get back to this. Why do we take the variation at the aircraft and not at the NDB? Why do we take that? Probably the very first reason could be that, but let's kind of dig a bit deep. We have studied the basic principle of how an aircraft finds the QDM. This is what the aircraft determines first, especially if you have an RMI, right? In case of RBI, you have to kind of add it out, but RMI can give it to you straight. So what the aircraft gives you primarily is the QDM, right? Now, how does the aircraft do that? That's by using the loop theory. Yeah, so NDB, the base principle of operation of an NDB. Which one? Oh, sorry. Bad. Can you see it now? Yeah. The principle of operation of NDB is bearing, finding the bearing, which is a QDM, by loop theory. We have studied the basic principle of operation, which is the loop theory before. The thing about it that happens at the ADF. And where is the ADF? The ADF is in the aircraft. So basically, the QDM is determined by loop theory, where the phase comparison is done on the vertical elements of loop antenna. And it is found out at the ADF part of the NDB system, which is in the aircraft, right? And for that reason, the QDM which you find out is in the aircraft, and therefore the QDR which you found out from the QDM is based on the value which you got at the aircraft. And therefore the variation which you have to use is that of the aircraft. Now think about it, you find the value at the aircraft and you apply the variation at the NDB, that will match. That's right? Yes, so that's exactly the reason why we use 20 degrees, which is the variation at the aircraft for NDB, and we get 175. Now this is the main part which I wanted to explain today. Now what we're going to explain now is just transferring this back here. We have done a couple of sessions here where we kind of did this actual scenario to chart conversion. Let's do that again. So we have this QDR, which is the track from the station, now in the form of a true value. So what have we found out here? So we have studied VDF, the older radio Q codes. So this is basically the true bearing or true track from station, right? And what is that? And that is nothing but QTE. That is the true track from the station. So what you got from QDR by applying variation is the QTE. It's a true track from the station. Now we are very, very good to apply this straight to the chart, because chart is also in the true platform. right? So let's see that now. From the NDB, you have a track of 175 degrees true, which is QTE. Take out your protractors, which you have. When you actually fly, you can keep them on the chart, and then you can kind of draw this track here straight. You can see a track of 175. So probably, yes, 175. This is degrees true, which is your QTE. The aircraft is at a distance of 50 nautical miles from the NDB. These things won't apply for distances. So take your ruler. As I've told you before, we have ruler sights depending upon your the scale of the chart. So be careful with that. So take the ruler, and now from the NDB, mark a distance of 50 nautical miles, and there you have the aircraft. Now you can also kind of imagine the heading of the aircraft being 200. Now, we don't generally mark the aircraft on the chart, and for that reason there is no kind of application of any variation and stuff, and more than that, it's just the heading over here, right? So basically we are trying to locate by the aircraft by putting a point, and that's it, you're here. And as I've told you earlier, what we just did now, you probably have to do most of these things mentally in the aircraft. You probably might not get a very stable aircraft to kind of draw and kind of measure all these things. Even if you get it, you have to do it pretty quickly, because the aircraft is moving, and if you take too much, like 2 to 3 minutes to do the whole thing, the aircraft would have actually flown a distance which was equivalent to its speed, right? So that's it. I hope you understood. What we are trying to explain here is why do we take the variation at the aircraft in NDB ADF system rather than not at the NDB. That's because the value which you find out, which you immediately get, is at the aircraft, and therefore the variation at the aircraft has to be used. Let's go to the VOR straight away. Now, it's always good to analyze these two things together because the difference becomes pretty obvious. What happens in a VOR system? I've always told you VOR for variation at the VOR, V for V.